Okay, good morning students. Today we will discuss fourth unit of engineering thermodynamics, entropy and availability. In third unit itself we mentioned directional feasibility decided by the second law of thermodynamics. How means if entropy is increasing, then automatically in that direction only the process can execute. Increasing entropy principle. We will discuss thoroughly inside the syllabus. Coming to the syllabus of the unit, in this entropy topic, Clausius theorem, definition of entropy, principle of entropy increase, and TS plots. Why? Because up to now we discussed only PV diagram. The area under PV diagram will give the maximum work output. Now we will discuss temperature and entropy diagram and change in entropy in various reversible process. Next one, second topic of this unit, availability. Once you know the entropy, you can calculate the availability. In that availability, one more name is there, exergy. So we will introduce definition of exergy and energy, expressions for availability and irreversibility. Next, availability in steady flow, non-flow process, and irreversibility. Some simple problems also we will solve from this unit. So, starting of the unit, Clausius inequality. Because Clausius, Rankine, Euler, Joule, these are the father of thermodynamics, we can call the basic foundations. So, Clausius introduced one inequality in cyclic operation, cyclic integral of dou q by t, always less than or equal to 0. Means in cyclic operation, summation of all heat interactions with respect to boundary temperature is always equal to 0 means reversible, less than 0 means it is irreversible, greater than 0 impossible. This inequality is introduced to Clausius. How we are proving means we are following P-Knock textbook model. One unknown reversible process I2F is there. Now I want to determine what is the heat transfer. I2F is the reversible process only, but it is the unknown reversible process. If known reversible process, I know the equations I can solve. Then now what I am doing, this unknown reversible process is substituted by known reversible process. But what is the condition? The area of the known reversible process under PV diagram is equal to area of unknown reversible process. Means work done. Area of PV diagram is work done. In both process, work done must be equal. Like that, I want to substitute the known reversible process. Here, one adiabatic process B2F and I2A, two adiabatic process parallelly introduced, and A to B, one isothermal process I introduced. So, the known process, the unknown IF is substituted by known IA BF. So I know the adiabatic process, I know the isothermal process. But what is the condition? The area of the known process, summation of known process under the curve, and area of the unknown process must be equal. In this condition, I can substitute work done is equal, change in internal energy also equal, whatever the process you are moving, internal energy is independent of the path. And then finally, unknown IF equal to known heat transfer. Known heat transfer QAIA adiabatic process, QBF is the adiabatic process heat transfer 0. So QAB isothermal process, whatever the heat transfer is taking place, that is only the heat transfer of the process. So like this. Now this now you select one unknown cycle. I want to determine the heat interactions. This unknown cycle is first divided by the adiabatic lines and further divided by the isothermal lines. So this unknown cycle is divided by known Carnot cycle because isothermal heat addition, adiabatic expansion, isothermal heat rejection and adiabatic compression. But what is the condition? The area of the unknown cycle in PVDI must be equal to the area of known number of Carnot cycles. Then we know heat to temperature ratio is equal. Then dou Q1 by T1 equal to dou Q2 by T2 for first cycle. Like that, n number of cycles. Then summation of this dou Q1 by T1 plus dou Q2 by T2 is 0. So finally, in reversible process, in cyclic operation, n number of cycles be completed. Dou Q by T equal to 0. The cyclic integral of dou Q by T for reversible process is 0. Some derivation how we can prove. But later Clausius is realized he is not introduced inequality, he introduced a new property which is the driving force especially for the flow process for determination of the available energy. What is that property equation means? Change in entropy ds equal to dou Q by T for reversible process. Irreversible process it is greater than, but it is an extensive property. We required intensive property, so divided by kg, kilojoules per kg Kelvin, we will get the intensive property. Then what is the definition of entropy? We know molecules in one vessel, we considered some molecules. They are in a random motion, no doubt at all. A collision of the molecules will take place, intermolecular attraction is there. In some disorderness is there. Once I supply some heat, this degree of disorderness further is increasing, further collisions are increasing. So entropy means the measurement of degree of disorderness, not absolute disorderness. Absolute we don't know. While performing some process, how much disorderness is increased, that is called entropy. That equation, entropy equation for the reversible process is dou Q by T. And next, entropy is a property or not? For reversible process, entropy is a property. Like that we selected three paths, path A, path B and path C. Initially path A I moved and returned to path B. Next time I moved path A and returned path C. In any condition, the magnitude is not changing, only direction is changing. So it is independent of the path. Entropy is a point function. It is a just property. That's why in steam table you can see specific volume, entropy and enthalpy. Next, inequalities we derived. In cyclic integral of dou Q by T equal to 0, it is a reversible process. Less than 0, irreversible process. Greater than 0, impossible process. Or ds equal to dou Q by T, reversible process. Greater than irreversible process. ds less than dou Q by T means it is impossible. Next, entropy increasing principle. Okay, in reversible process we mentioned entropy is dou Q by T. For irreversible process it is greater than dou Q by T. Means some entropy generation will take place based on the process. So entropy is the, for reversible process entropy is a property. But irreversible process, whatever the entropy is generating based on the process, then it is not a property. It is a path function, not a point function. How we are calculating entropy generation based on the process? Or system entropy we determined, surrounding entropy we determined. System plus surrounding. System entropy may be minus, surrounding entropy may be minus or plus. But the summation of system plus surrounding entropy, change in entropy, always greater than 0. Means change in entropy of universe always greater than 0. While we are calculating some problems, I will show the problems. System we may get negative. surroundings we may get positive. But summation always positive. That is the increasing entropy principle. In that direction only our process can execute. In rare condition, if system and surrounding both we can achieve reversibility is a hypothetical assumption only. In that condition only we will get the 0. Not less than 0. Always greater than 0. This is called entropy increasing principle. S generation always greater than 0. Rare case equal to 0. One example problem we can solve, then we will get a clear idea. A heat source at height 800 Kelvin loses 2000 kilojoules of heat. The source temperature is fixed 800 Kelvin. Heat also fixed 2000 kilojoules. To the sink temperature initially 500 Kelvin, later 750 Kelvin. So sink temperature initially 500 Kelvin, you can determine change in entropy. It is losing means negative, heat loss is negative. Then source temperature, change in entropy is minus 2.5. Sink is plus 4, 2000 by 500. But S generation, system plus surrounding, always positive, I already mentioned. System may be negative, surrounding may be positive, but total is always positive, 1.5 kilojoules per Kelvin. And next, same, it is, next source is same, so minus 2.5 kilojoules per Kelvin. Sink is changing 750 instead of 500. Then sink change in entropy is 2.7 kilojoules. But S generation is again positive, the value is reduced. So, if we are reducing the temperature difference, automatically the change in entropy is reducing. That's why, especially for household utilities or thermal applications, low temperature thermal applications, utilization of the biomass and electrical energy or gas almost removed. At present, they are using solar water heating system. Because solar temperature, maximum source temperature is 90 degrees, 80 degrees. Our utilization also 50, 60 degrees. Earlier condition, gas or biomass, electrical energy we are using at least 300 to 400 is the source temperature. High temperature difference, high entropy generation, the available energy is reducing. One of the application of entropy. Next, we already mentioned finite temperature difference leads to entropy generation. We already proved in the problem. Same, suppose this is a system is transferring heat to the B. So A temperature is higher than the B temperature. Then the change in entropy of A is, because it is losing heat, so dou Q by T1 plus T2 is next to B system is gaining the heat, so dou Q by T2, it is the positive. Finally dou Q into T1 minus T2 by T1 T2. Surroundings, it is insulated, we are assuming surroundings is 0 for simplification of the problem. Next, universe is Q into T1 minus T2 by T1 T2. T1 is always higher than T2. So, always entropy generation of the universe is positive. While temperature, finite temperature difference always leads to entropy generation, irreversibility. Second one, mixing also. If two different fluids having different temperatures, different specific heat, different masses, we are mixing, automatically the entropy change, it is reaching initially T1, one mass of the fluid. Next to another mass of fluid is temperature is T2. While we are mixing these two masses, it will reach intermediate temperature, that is called TF. Then change in entropy of gas A, M1C1 ln TF by T1. And change in entropy of gas B, from T2 to it will reach TF. So M2C2 ln TF by T2. If M1 equal to M2, C1 equal to C2 for simplification of the problem, then automatically TF equal to T1 plus T2 by 2. Now you substitute MC ln TF square by T1 and T2. Then final equation 2MC ln T1 plus T2 by 2 divided by T1 square root of T1 T2. The change in entropy of the universe is arithmetic mean by geometric mean. We all knows arithmetic mean always higher than the geometric mean. So mixing also leads to entropy generation. Because arithmetic mean always positive. Automatically ln numerator is high. Automatically it will give the positive value. So mixing also leads to entropy generation. Final temperature difference also leads to entropy generation. TS plot in constant temperature line we are representing horizontal. Constant entropy or adiabatic line we are representing. Entropy is constant means in vertical. The area of TS diagram T into change in entropy T ds equal to heat transfer, because ds equal to dou Q by T, dou Q equal to T ds. Automatically it will give the maximum heat transfer of TS diagram. Next, coming to the slope of constant volume and pressure, dt by ds equal to T by mcv constant volume, mcp constant pressure. Cp is higher than the Cv, automatically constant volume line having the highest slope compared to constant pressure lines. These are the representing of the graphs in TS diagram. So Carnot cycle we are representing A to B constant temperature isothermal heat addition, B to C adiabatic expansion, next C to D isothermal heat rejection, and D to A adiabatic compression. This is the representation of the Carnot cycle in a TS diagram. So the area under AB curve total is the heat supply. The area under DC curve is the heat rejection. Heat supply minus heat rejection, we will get the maximum work done. Next, entropy change in entropy for non-fluent flow process. Simply we are representing dou Q minus dou W equal to du. Then dou W equal to PdV, dou Q equal to TdS. If you substitute, finally you will get the Cp, C average into Cv into ln T2 by T1 plus R ln V2 by V1. The next equation for flow process, H equal to U plus PV, dH equal to du plus PdV. Now only we represented du plus PdV equal to TdS. We substitute TdS equal to dH minus VdP. Then final equation for flow process is Cp into ln T2 by T1 minus R ln P2. This is the common equations for flow process and non-flow process. If in the problem they are not mentioned particular process, they mentioned flow process or non-flow process, directly you can use these equations. Next, change in entropy for liquids. There is no change in specific heat, so it's a constant. C average into ln T2 by T1. For coming to the gases, the specificity is changing. Constant pressure process Cv, constant volume process is Cv. So reversible constant pressure process MCP ln T2 by T1. Constant volume process MCV ln T2 by T1. Coming to the isothermal process, we know heat supply equal to work done, then PdV by T or Mr by V. P by T equal to Mr by V. Final equation Mr ln V2 by V1. And reversible adiabatic process, here dou Q by T, dou Q is 0. So the change in entropy is 0. So reversible adiabatic process, one more name is isoentropy process. Next, irreversible adiabatic process, it is greater than the dou Q by T, means it is greater than 0. Next, isoentropic efficiency of turbine. Actually, next, isoentropic efficiency. I already mentioned isoentropic process means entropy is not changing, means there is no heat loss. Heat loss means whatever the change in internal energy of the system, total will convert as a work. That is the main beauty. But in a practical case, always some heat loss will takes place in turbine or compressor. Due to that heat loss, whatever the work output we are expecting, that adiabatic process or isoentropic process, that we will not achieve. So how much loss will occur? That is called isoentropic efficiency. In turbine point of view, actual turbine work output by isoentropic turbine work output. Because due to loss, actual work output always less than the isoentropic work output. From the steam tables we are calculating the isoentropic work output, and manufacturer will provide the isoentropic efficiency of turbine. Generally 85 to 95% efficiency. If capacity megawatt range is increasing, automatically the isoentropic efficiency of turbine is increasing. Like compressor also. In compressor we are calculating energy input. In actual case some heat loss will occur, so automatically energy input is increasing. So isoentropic efficiency of compressor equal to isoentropic compressor work input in isoentropic process. Whatever the work input we are calculating, it is less than the actual work input. Why? Because actual work the actual work input we want to add isoentropic work input plus heat loss also we wanted. Then actual work input is high. The generally isoentropic efficiency of compressor, it is varying from 75 to 85%. Next, move to the third law of thermodynamics. Because the measurement of molecular disorderness, where the all molecules are in ordered position. Third law only explained. At 0 degree Kelvin or minus 270 degree centigrade, all molecules are coming in order. There is no disorderness exists in the molecules, all in ordered position. At that temperature, whatever the entropy we are measuring, that is called absolute entropy. The temperature is absolute zero. At absolute zero temperature, the entropy, absolute entropy is zero. There is no molecular design. This benchmark is provided by third law of thermodynamics. When the molecules, the change in entropy is zero, means at 0 Kelvin degree centigrade, all molecules are coming in ordered position. Next small problem you can solve. Then we will get clear idea about change in entropy and all. Suppose a Carnot engine operating between the temperatures 1000 Kelvin and 300 Kelvin. So source temperature is 1000, sink temperature is 300. Then the change in entropy of source they given. So change in entropy equal to dou Q by T1 source. So we want to determine the dou Q. So automatically dou Q equal to T1 into delta S. We can determine the 600 kilojoules is the heat supply. Efficiency you can calculate because you know source and sink temperature, then 70% efficiency. Efficiency, one more equation, net work output by heat input. Then work output equal to heat, heat input into efficiency. Simple problem. One more problem. 1 kg of water is placed in an insulated container and work is performed on the water by stirring device causing 10 degrees rise in temperature. Initially whatever the temperature is there, by this stirring operation 10 degrees rise, the delta T is 10 degrees. The initial temperature was 40, so final temperature is 50. Consider as isolated and neglecting thermal capacity of the content, determine the entropy. I already mentioned liquids and solids, just MC ln T2 by T1. C, specific of the water, if they provide or not, you have to assume 4.2 kilojoules per kg Kelvin. ln of T2 by T1. T2 is 50 degrees plus 273, 323 plus 40 degrees plus 273, 330 degrees. So finally change in entropy is 0.132 kilojoules per Kelvin. Simple problem. Only this 10 degrees. It reached 10 degrees, you are assuming means negative value will come. Rise to from initial to 10 degrees added, then it is we will get the right answer. Then one more change entropy problem. 10 grams of water. 10 grams of water at 20 degrees is converted into ice at minus 10 degrees. So heat loss is fixed. Initial 20 and minus 10 degrees. Specific heat of the water we know 4.2 kilojoules per kg. Ice is half of specific heat of the water, so 2.1 kilojoules per kg. Next, the latent heat of fusion of ice is 335 joules per gram or kilojoules per kg. Whatever. Mass given grams, so we maintain all are joules per gram Kelvin, not kilojoules per kg. Already latent heat they given joules per gram. So here directly we can't calculate the change in entropy. First thing you will get negative value because heat loss we are rejecting, so negative value only will get. Second, how many phases are there? First divide the phases. First liquid phase 20 to 0 degrees. Write the equation mCp ln T2 by T1. T2 is 0 degrees means 273, initial 20, 293. Okay. Next 0 degrees water to 0 degrees ice. So latent heat. So minus 335 by dou Q by T. What is the temperature T? 0 degrees 273 into how many kgs? 10 kgs plus 0 degrees to minus 10. Again is solid condition. The specificity 10 kgs only, mass is not changed. Specificity is 2.1, half of the liquid, and ln of T2 by T1. T2 is minus 10 means 273 minus 10, 263 by 273. Finally we will get minus 16.0. So first divide the phases. How many stages are occurring? Each stage you write the equation. That's all. Simple. Next, availability, available energy, exergy. Suppose at the room temperature, plenty of the heat is available. What is the use? You can convert that heat to some other useful form. No. At sea level, 96% of the water is available. Because in total globe is covered 97% only water. At sea level what we will do? Suppose that water is available at Himalayas, Gangotri, Yamunotri, like that. Then after melting 3 kilometers, 3.5 kilometers head, then Haridwar, Rishikesh, it is down to 2 kilometers depth. Then in between so many power plants they constructed, they are generating electrical energy. But same water is available at sea level, there is no use. So available energy is different. Generally, the definition of energy means all or no, so from childhood and capacity to do work. What is exergy or available energy? One more passionate name is exergy. That's all. Exergy not a new technology. What is exergy? Capability to do work. I already mentioned. Plenty of water is available. The mass into some heat value. But that is capable to convert or not? There is no capability. Then the exergy value is 0. One more regular example I will give, then you will get a clear idea. Exergy. I have 10,000 rupees in my account, in my pocket. I am interested to open a bank account. Any bank ready to accept without surety, introducer, they will allow. But private banks minimum balance is 4,500, 2,500 like that. Government SBA, urban is 1,500, rural is 500. Minimum balance. Grameen bank like that means minimum balance is 100. If I open the account in different banks by using the 10,000, my capability is changing. My capacity is 10,000. If I opened in private banks, my capacity is not changing. 10,000 only I deposited. In government bank or private bank, my capacity is 10,000. But my capability bank to bank is changing. One bank, my capability is 6,500, one bank 9,500, one bank 8,500. Like that, my capability continuously changing. So based on the dead state condition, the minimum balance. Like this, exergy means capability to do work. That capability, how we are calculating means from the current state to dead state. We are moving reversibly. What is the maximum extractable energy, maximum convertible work potential energy we are calculating? That is only your capability. Remaining energy we can't convert. Out of that also, in actual condition, it may reduce also. So, exergetic analysis, it is more useful to determine the what is realistic available energy, work potential energy. So, how we are calculating is based on the dead state only. So, we want to know the dead state condition. Suppose simple heat is there. We multiply with the Carnot cycle efficiency 1 minus dead state temperature by current state temperature. We will get work max or heat supply minus Q by T1 into T0 means delta S. Q1 minus T0 into delta S. Here T0 into delta S is the unavailable energy. Q is the total energy. Total energy minus unavailable energy, we will get the work potential. That work potential only the available energy. A simple heat is available. We can calculate easily. Otherwise, a general equation for non-flow process and flow process. Non-flow process, you know, the availability of current state P1, V1, T1 and end state P2, V2, T2. The dead state is P0, V0, T0 suppose. The availability of initial state from P1 to P0. The availability of final state. Why? Because we can't move to up to dead state. Suppose I want to maintain condenser. The ambient temperature is 35. My condenser temperature I can't move 35. If it is moved 35, heat loss will not take place. If condensation of the steam is not takes place, my cyclic operation will not execute. So, the availability of the initial state minus availability of final state will get the available energy. How we are calculating the maximum work output means dou W is equal to dou Q minus du. When I will get the work max, minimum heat transfer. Minimum heat transfer when T0, the dead state condition only minimum heat loss. T0 into ds minus du. T0 into S2 minus S1 minus U2 minus U1. Then finally work max equal to U1 minus U2 minus T0 into S1. Availability of initial state U1 minus initial state minus dead state minus T0 into initial state entropy minus dead state entropy. And availability of second U2 minus U0 T0 into S2 minus S0. Work max equal to Pi1 minus Pi2. Like that steady flow process. Instead of internal energy, here we are getting enthalpy flow process. Same. What is irreversibility? The entropy, change in entropy of system plus surrounding into T0, that is the unavailable energy. That is only the irreversibility. Or work max minus actual work. That difference also called irreversibility. The actual work by the system is always less than the idealized reversible work. The difference between two is called irreversibility. Some problems we can solve, then we will get the clear idea about this available energy. Suppose a vapor condenses at 1000 Kelvin, rejecting 3000 kilojoules of heat. Another vapor condenses at 500 Kelvin, rejected same amount of heat. Find the difference in available energy between these two processes. Take sink temperature as 300 Kelvin. So, heat rejection is same, 3000 kilojoules. But the condensation temperature is different, 1000 Kelvin and 500 Kelvin. If it is condensed 1000 Kelvin, what is the available energy? If it is condensed at 500 Kelvin, what is the available energy? Work max equal to total energy minus unavailable energy, T naught into delta S, or directly it is given heat. So Q into 1 minus T naught by T1. If any method you calculate, the available energy is 2100 kilojoules. Actually 3000 kilojoules, but available energy if it is condensed 1000 Kelvin is 2100 kilojoules. Same way for condensed at 500 Kelvin, same method you can calculate. The available energy you are getting 1200 kilojoules. Out of 300, only 1200 is available. What is the loss? 900 kilojoules loss. If same energy condensed at 500 kilojoules instead of 1000 kilojoules. Here one more problem. Hot gas at 5 kg per second in a furnace at 1027 degrees centigrade. So the source temperature is 1027 degrees centigrade, means plus 273 means 1300 degree Kelvin, and the sink temperature is 327 degrees centigrade. So that heat engine, reversible cycle heat engine, is working between the 1300 degree Kelvin to 600 Kelvin. Then dead stage temperature, surrounding temperature is 27 degrees centigrade. The specific heat Cp of gas, because constant pressure process they mentioned. So they given Cp 1.1 kilojoules per kg Kelvin. Here we want to determine available energy and unavailable energy. So if you determine the unavailable energy, automatically you will get the available energy. So the total energy is mCp delta T. This is the heat supply to the heat engine. 1300 minus 600 into specific heat is 1.1 and total mass flow rate is 5. This is the 3850 kilojoules per second. And then change in entropy mCp ln T2 by T1. This is at 1300 by 600. So you will get 4.253 kilojoules per kg Kelvin into T naught into 300 into 300 means 1200 kilojoules per second is the 1200 kilojoules per second is the unavailable energy. 1200 minus 3850 means around 2650 is the available energy. So one more problem. 1000 kilojoules of heat supplied to the reversible cycle engine at 327 degree centigrade. The surroundings is at 27 degree centigrade. Find the available and unavailable energy. Simple. First determine the efficiency 50%. Work max equal to heat supply into efficiency. Automatically 500 kilojoules. 1000 into 0.5, 500 kilojoules. The available energy is 500. Unavailable energy, total energy means available energy is equal to unavailable energy. Or unavailable energy you can calculate T naught into delta S Q1 by T1. Then you will get the 500 kilojoules. One more problem. A Carnot cycle, heat supplied 350 degrees centigrade, rejected at 227 degrees centigrade. So source temperature is 623 Kelvin and sink temperature is 300 Kelvin. The entropy change is 1.44 kilojoules per kg Kelvin. Next, heat supply Q equal to T into delta S. T we know 623 plus delta S already source delta S they given 1.44. So heat supply we calculated. Efficiency is 1 minus T2 by T1. The efficiency is 51.8%. Net work done equal to efficiency into heat supply. You will get the net work done. Next, last problem. In a process where mercury is condensing at 327 degrees centigrade, transfer heat to 10 kg of saturated water evaporating at 227 degrees. So heat source is 327, but where we are using at 227 degrees. How much energy? 10 kilojoules of saturated water is evaporated. So latent heat of water Vaporization of water at 227 already given 1941. So 10 into 1941 is the total heat. But that is available at 327 but utilizing at 227. So change in entropy, you can determine the unavailable energy T naught into delta S dou Q by T1, initially 600 degrees centigrade. So this is the unavailable energy 9705 out of 19,400. If same heat we are utilizing at 500 Kelvin, then you calculate the unavailable energy is 11,000 out of 19,000. So the increase in unavailable energy is almost 1941 kilojoules is increased because of source is 327, utilization is 227. This is the main reason. So these are some problems we discussed. Some more problems you can practice. For the final target, total energy capacity to do work we know, calorific value of all fuels we know. But how much work potential, work convertible potential we can extract, that calculation only based on the entropy we can calculate, that is available energy, exergy, available, different names we are calling. That is main important for our problems, for our real time industry application. Capacity there is no use, capability is important. So I think we initiated work, thorough discussions will move in the next higher education. Thank you very much.